Okay, so for this video, I'm going to show you how to set up a dimensional analysis line that has more than one step included. So instead of doing it in two different parts, we're going to do it in actually one straight dimensional analysis line. So we first did this one up here with silver nitrate. Let's go ahead and do the next one, which is water. Okay, our substance is water, and we know the number of molecules for this one. Okay, that's our given. So our given is 2.8 times 10 to the 24th molecules of H2O. Okay, and we're wanting moles, and we're also wanting the mass, which, by the way, these are in grams. Okay, so we need to set this up to convert all the way until we get to the grams. In order for us to be able to make two jumps like that, we're going to need the molar mass. The molar mass is the key here. So water, H2O, has a molar mass, and we abbreviate that mm, of, here it is, hydrogen is 1.01 grams, and there's two of those. Okay, that's 2.02 grams, and oxygen is 16 grams. Okay, so 16 plus 2.02 is, it's a little messy, 18.02 grams is the molar mass of water. Okay, so that's water. Okay, so we're going to write that in over here. We're going to use that as our conversion factor here. In a minute, we're going to use that. We're starting with an object. We're starting with molecules, and we're trying to get to the mole. So the first conversion factor that we're going to use is actually Avogadro's number. So we have our molecules, which is 2.8 times 10 to the 24th. Set up the dimensional analysis times line. I want moles. That's the thing that's right next to it. So I'm going to put what I want on top, the moles. 1 mole is equal to 6.02 times 10 to the 23rd molecules. Okay, and I'm going to keep going. I'm going to set up the next step, because after I get molecules, I actually want to get the, after I've got the mole, I want to get the mass in grams. And so in order to do that one, I'm going to set up another dimensional analysis. So times line, I'm going to be converting in that case from moles to grams. So 1 mole of water, H2O, I've calculated to be 18.02 grams. Okay, now I've got a dimensional analysis line, and I'm going to solve this through quickly because it's set up really nice to do so. I'm going to cancel out the things that I can cancel out. So molecules is on the top and on the bottom. Moles are going to get canceled because they're on the top and on the bottom. I'm going to multiply the numbers on top like so, and then I'm going to divide to the number on the bottom. And then I'm going to do the next step, the same thing. I'm going to multiply, and then I'm going to divide to the number on the bottom. All right, so let's see what we get. So I've got 2.8 times 10 to the 24th, and I'm going to be dividing to 6.02 times 10 to the 23rd. Okay, and I ended up getting 4.65. 4.65 times 18.02, and And that gives me 8.38 times 10 to the 1 grams. Of water.